Alrighty, so this is back by somewhat popular request to do a walkthrough of the cash cab problems. So we're going to start, coming back where this is the February-March 2019 paper 1 exam. This is 1-2. So if you want to look up more information, you can look that information up on the internet, and it will direct you to some videos. So this one, starting with 1, the coefficient of x cubed in the expansion 1 minus px to the fifth is negative 2160. Find the value of p. So what we're looking at is we've got to do the expansion first. And we don't want to do the whole thing. We're just looking for x cubed. So we have 1 times negative px. We're going to set it up that way. Pen's a little bit bigger here. And we're starting our n is 5. So it's 5, choose something. We know we want it to be 3, so this is 3. And then this spot is n minus r, so it's 5 minus 3, so that's 2. So we know that negative 2160 is going to be equal to 5, choose 3, 1 times negative p cubed x cubed. Now, we don't actually care about the x cubed. We're just looking for the rest of it. So you have to figure out 5, choose 3. 5, choose 3, you can put it in your calculator, or you can use the formula, which is n factorial over n minus r factorial times r factorial. But as I've said before, use the tools available to you. You have a calculator. Don't work harder than you need to. So you're going to do 5, and if you're using the TI-36X Pro, you're going to double tap the and choose R key, and then you're going to select 3. You're going to get 10. So you're going to get 10 times 1 times negative p cubed. I'm going to divide by negative 10. So this gives me 216 is equal to p cubed. So then you can take the cubed root of 216, and you get p equal to 6. So there you go. That's how you do problem 1, 3 points. So let's go on to the second problem. So this is an integration problem. So this is a curve passes through these 2 points, given that this is the function where k is the constant, find the value of k. So what you do is you have f prime of x equaling kx squared minus 2x. Now, where with differentiation, we multiply and then subtract. Integration is you add and then divide. So this is going to be k. We add first, then divide. Add first, then divide. And then your constant of integration. So with this being the case, now we have 2 points. So we know 2 is equal to 0 minus 0 plus c. So that makes c equal to 2. Now that we've got that, we can rewrite it. We can say f of x is k x cubed over 3 minus x squared plus 2. And then we can plug in our other point, which is 3, negative 1. So negative 1 is equal to k 3 cubed over 3 minus 3 squared plus 2. So 3 cubed over 3 is 3 squared. So this is 9k minus 9 plus 2. 9k minus 7. So we add 7 to both sides. It's going to be 6 is equal to 9k. So then k is 6/9 or 2/3. So there you go. There's that one. Going on to the next one. This one was fun. So what this one is asking for is, it's telling us that this semicircle has the radius of 7. It's telling us this sector has the radius of 8. So what you have to do is you're going to find the area of this of that, subtract out the triangle, and then add in the area of that. Now visually that's not the best way, but so it's going to look like this. Remember, follow our steps. So our formula here that we're going to look for is area of the shape is area of the semicircle plus area of the sector minus area of the triangle. And now you just plug these in. So area of the semicircle is 1/2 pi 7 squared. So it's going to be 49 over 2. 49 pi over 2. Then you have area of the sector, which is pi r squared theta. Well, we know r, but we don't know theta. Theta is some unknown. So we have to figure out what theta is. So we have this triangle that's 7, 8, and we just have to figure out what this is for the base. So that's going to be 8 squared is 49 plus x squared, the square root. Nope, not the square root. So it's 64 minus 49 equaling x squared. Gives you x as the square root of 15. So we could write the area of the triangle then. So the area of the triangle is 14 times square root of 15 all over 2. And then now we just have to figure out what theta is. Well, theta, so I'm going to use what we're given just in case I'm wrong. Now that's a technique that you can use. If instead of using the number you calculated here, try to use what you were given just in case you were wrong. You're always using what you're given. So we're looking at hypotenuse and opposite. So sine of theta is 7 over 8. So theta is equal to sine inverse of 7 divided by 8, which is 0.76 radians. I don't think this was right. Calculator's in the wrong mode. 61.04 degrees. Now remember, hold this value in your calculator. Don't just round it right here. but we've got to double that. So I think we now have everything. So we can go to the area of this is 49 pi over 2 plus pi 8 squared times our theta, which is 122.0899 degrees, minus 14 square root of 15 over 2. So we've got so this is 49 pi over 2 See, this right here is how I know my problem's wrong already. This must be in radians because we're using pi. So I've got to go back up, got to change my mode, sine inverse of 7/8. That doesn't help. This is actually times 2.13 radians. So this simplifies to 505.4. And then we're going to subtract 7 square root of 15. 78.29. So I think that should be somewhere close to the right. So here we go. Let's see. So now that we've got a couple of them done, let's go back and look. Switch to the highlighter and we'll look at the mark schemes while we do this. So P equals 6, that's 1 point. Cubed root then divided, this right here was worth 1 point. And then the formula was worth 1 point. Those are the 3 points. Going on to the next one. Attempting the integration, so that was worth 1 point. Actually, that's worth 2. 1 point for the action, 1 point for getting it correct. 1 point for substituting, getting C is equal to 2. 1 point for substituting to get to this point. And then 1 point for K equal to 2/3. 2, 3, 4, and then that makes 5. Now we're on to this one. So this one, let's see. So looking at it already, you can see we went AWOL somewhere. So let's see what we got. Sine inverse of 7/8. We did that. And 1.06, yep, did that. And then 64 times 2 times that. Oh, we've got that. All right. And then 7 times that. We've got everything right. 49 pi over 2. So this is correct. That is correct. So let's redo this last one. So this is 27.11. And then this would be I forgot this is 1/2. There's no pi. That's what I forgot. I gotta use the right formula. So it's 1/2 r squared. There we go. Minus 27.11 gets me in the right ballpark. There we go. That's what I did wrong. This is what I get for not using a formula sheet. Alrighty, so we're going to try to clean this up a little bit. So back to this step. We took our formula, now we plug stuff in. So 1/2, we're going to rewrite that. So this is going to be pi. Our sector is 7, so it's going to be 49 pi over 2. Then we're going to add to that r squared, which is going to be 64 times the angle, which the angle is going to be this. So theta is equal to 2 times sine inverse of 7/8. In radians, so that's 64 times 2.13 all over 2 minus our base, which is going to be 14, our height, which is the square root of 15 all over 2. So it ends up being 49 pi plus 136 minus 14 square root of 15. All over 2, and then that simplifies to 236 over 2, which is 118.04. There you go. So that's that one. So let's move on to the next one. So this should be pretty straightforward. We have an equation. We need to find first and second derivative. So our y is 2x minus 1 to the negative first plus 2x. So dy dx. So first is the chain rule, so we're going to multiply the outside we're going to take the derivative of the outside, so negative 1 negative 1, 2x minus 1 to the negative 2 power times the derivative of the inside, which is 2, plus 2, derivative of the second term. Simplifies to negative 2 over 2x minus 1 squared plus 2. And then the second derivative we're going to multiply, so negative 1 times negative 2, 2x So this is actually going to be negative 2 times negative 2 times 2 2x minus 1 to the negative third power plus nothing. So this is going to be 4 over 2x minus 1 cubed. Oh, times the derivative of the inside. So this is actually 8. So there's part 1. Now we're going to take a look at part 2. So part 2 is find the nature of those points. So the nature is where first we need to find the stationary points, and we need just the x-coordinate. So we're looking at our first derivative. First derivative equal to 0. And our first derivative was negative 2 over 2x minus 1 squared plus 2. So we just evaluate. So we get negative 2 equals negative 2 over 2x minus 1 squared. Negative 2, 2x minus 1 squared equals negative 2. So I moved 2 over, and then I multiplied both sides by 2x minus 1 to get rid of the fraction. Those will cancel. So 2x minus 1 squared equals 1. So 2x minus 1 equals 1. Take the square root. That'll be plus or minus 1. So that gives us 2x minus 1 equals negative 1, and 2x minus 1 equals positive 1. So x equals 0, and x equals 1. So those are our 2 points. Now we look at the second derivative, which was 8 over 2x minus 1 to the third power. So when x is equal to 0, You get negative 1 cubed, which is negative 1, so we get negative 8. So this is a max. Then you do this one. So 2 minus 1 is positive 1. So that's 8. It's positive. So that's a minimum. So you go back and look. Did we find the stationary points? Yes. Did we determine the nature? Yes. So we should be good there. Let's look at the next one. So this is 5. 5 we're going to skip over because it's a vectors problem. So we're going to go to 6, looking at the terms for an inequality. So geometric, so we're talking we're talking nth term is a r to the n minus 1. So 2p is equal to p r 1 minus 2 minus 1. So 2p equals pr. R is equal to 2. So A is P, R is 2. So the first and second terms where P is opposite, the sum of the first n terms is greater than 1000 P. So the sum of n, so R is 2. So we have to be careful which formula we use. We're not going to use the one that's in the formula sheet because that's R less than 1. So we have to flip it. So it's A n r to the nth minus 1 over r minus 1. So the sum of the first n terms is greater than that. (1000p). So A is P, r to the n minus, 2 to the n minus 1 over 2 minus 1. So that gives us 1000p less than 2np minus p. You can divide both sides by p. 1000 less than 2n minus 1. There we go. So that's number 6. So now we're looking at an arithmetic. So the nth term is 2a the nth term is a plus n minus 1 d, and the sum of n terms is 1/2 is n over 2, 2a plus n minus 1 d. So the first and second terms are p and 2p. So again, we follow the steps. So 2p equals p plus 2 minus 1 d. So p is equal to d. So the nth term is 336, and the sum of the first n terms is 772. We need to find n and p. Well, the nth term is 336. Our first term is p. n minus 1, and our common difference is p. So 336 is going to be p plus np minus p. So 336 is equal to n. 336 is equal to np. I think that's all the farther we can go on that one. So let's switch to the sum of, so 7, 2, 2, 4 is equal to n over 2, 2p plus n minus 1 times p. Seven 22 4 times 2 is n. 2p plus np minus p. Which will be 2np plus n squared p minus np is n squared p plus np. And so this is going to be n times np plus np. So we can substitute then. So 7 to 2, 4 times 2 is equal to n times 336 plus 336. So 7224 is equal to 168 n plus 168. So subtract 168 and then divide by 168. You get n equal to 42. So 336 is equal to 42p. So then p is equal to 8. So there we go. We found p. We found n. All right, going on to the next one. Solve the equation 3 sine squared. Okay. So we're going to solve this equation. So we're going to have 3, 1 minus cosine squared 2 alpha plus 8 cosine 2 theta equals 0. So this is going to be 3 minus 3 cosine squared 2 theta plus 8 cosine 2 theta equals 0. So negative 3 cosine squared 2 theta plus 8 cosine 2 theta plus 3 equals 0. So it's a quadratic. So you can put that into your equation, and you get cosine of 2 theta equaling negative 1/3, or 3. And we know 3 is not a solution because it's outside the domain. So we do this. So we know that 2 theta is equal to 109.47 degrees. So theta is equal to 54.73. All right, so now we have to think of cosine. So we're going to think of cosine. It falls and comes back, and it's 2 theta, which means that it's 360 over 2, so 180. So this is no longer 360. This is now 180. So we're looking for negative 1/3. So we're looking for these two values down here. This one being 90. So this one's 54, and now you just have to look for the other side. So it's going to be 180 minus that 54 number. And this one is 180 minus 54, or 125.26. So that's that part. Now, this is the graph measured in radians. So we're going to put calculator back in radian mode. The curve intersects the x-axis at that y-axis. That find the values of a and b. So we've got square root of 3 equal to a plus tan of b 0, right? Tangent of 0 is 0, so this goes away, so a is equal to the square root of 3, and then you go do it again. So 0 is going to equal square root of 3 plus tan of b of negative b pi over 6. So negative square root of 3 equals that. So you get negative 1.04 equaling negative b pi over 6. Multiply both sides through by 6. Negative 6, so 6.28 equals negative b pi. Divide by pi, and suddenly things clear up. B is equal to 2. So there's B, and there's A. So here we go. So I need it in terms of A and B. So 2x minus 4 equals 0. 4 equals 2x. X is equal to 2. So this is x plus 2 squared plus the y value of that. So 4, so it's going to be 4 minus 8 plus 7, which is 3. So you can do complete the square if you remember how to do that. That's fine. You can also use the derivative to help you get into that, which is what I did. I took the derivative, set it equal to 0 because I know that's the stationary point. And the stationary point happens at x equals 2, so that has to be my a value. And then if you plug that a value into your original equation, that gives you the y coordinate of the vertex, which is your b. Okay, so now the function is defined for x less than k, where k is a constant. State the largest value of k for which f is a decreasing function. So let's look at it. We're a positive quadratic. So decreasing is going to be this side, increasing is this side. So x needs to be less than k. K needs to be the x coordinate of the vertex. So x less than 2, k is equal to 2. Okay, now k is now 1. So k is now over here. Find the expression. Okay, so I'm going to jump domain that is the range of your input, of your original. So if our domain, if we're looking at 1, our range, if we plug 1 into the original equation, is 12. There we go. That's better. We plug in 1. 1 minus 2 is negative 1. Negative 1 squared is 1. So that's 4. That makes sense, because if we plug 1 into the original, we get 1 minus 4, which is negative 3. It's positive 4. So that's right. So that's 4. And we go up to the range of this is y greater than or equal to 4. So the domain is x greater than or equal to 4. X greater than 4 because it's not equal to up here. So now we just have to take the inverse. So y is equal to x minus 2 squared plus 3. Y minus 3. Okay. Now you have to determine, are you going to be the positive one or the negative one? And given where the domain is, since we're on the decreasing side, I know we're going to be the negative solution. So it's going to be 2 minus the square root of y minus 3 equals x. So then 2 minus the square root of x minus 3 equals f negative 1 of x. So there we go. And then x greater than 4, which is indeed what they were looking for. Now we go on. Now we've got another function. So we're going to go back and look. So x greater than 1. So if x is greater than 1, that means f of x is greater than 4. So we're going to need that. So what was f of x? X minus 2 squared plus 3. So that's the original. And it's f into g of x, so g f of x is 2 over x minus 2 squared plus 3 minus 1, which then is 2. There. And then from there, we just have to figure out the range of g of x, or of g of f of x. Well, if the input into g of x, the smallest value is 4, well, what happens if we plug 4 in to here? If we plug 4 in to x for g of x, so which is equal to 2/3. So we're going to be between 0 I don't know why it's shorting out, but that should be g of f of x in there is less than 2/3. So there we go. So we got question 9. I'm going to skip 9 for right now because we haven't covered that. This is a bounded by the curve. Volume of revolution. So we haven't covered that yet, so I'm going to go ahead and skip that one. And we'll go to problem 10, the last one. So the straight line with the equation y equals x plus 3 intersects the curve at points A and B. So it's just a matter of x plus 3 equaling 4x to the 1/2. And so this is going to be x plus 3. Okay, so we're back to this one. So we've got x minus 4x to the 1/2 plus 3 equals 0. Recognizing that this is now a quadratic. A is equal to 1, B is equal to -4, and C is equal to 3. So we can solve this one. So we get, it's not x, so we get x to the 1/2 going 1 or 3. So x is 1, x is square root of 3. So those are x's, so it's going to be 1 comma, we plug 1 in, we get 4, and then we plug in square root of 3, we get 12. Now I have to find the distance. So distance is equal to x equals 1 or... Oh, oops. 1 or 3, so x is 1 or 9. So we look at this again, so 1 comma 4 and then 9 comma 12. So there we go. And then we're going to take the square root. So it's the change in x plus the change in y Okay. So 12 minus 4. So 64 plus 64. So 8 square root of 2 is what that simplifies to as the distance, which is approximately 11.3. So that's that one. Let's see what else we got. So the tangent to the curve at point T is parallel to AB. So we have to take our original function, which is 4x to the 1/2. So y equals 4x to the 1/2. And parallel to line AB. So the slope of line AB is 1. Looking at the equation. So dy dx is 4 times 1/2 x to the negative 1/2. So 2 over the square root of x, and we're setting that equal to 1. So the square root of x is equal to 2, so x is equal to 4. So it's 4, comma, plug it back in, is 2, so that's 8. And then we're finding the coordinates of the point of intersection of the normal to the curve at t. So the normal to the curve at t. So we know the slope at t is 1. So its normal is negative 1. And find the coordinates of the point of intersection of the normal and the line AB. Okay, so line AB is y equals x plus 3. And our point T, so it's y minus 8 equals negative x plus 4. So y equals negative x plus 12. So we get negative x plus 12 equals x plus 3. So 9 equals 2x. X equals 4.5. So we plug that back into any of them. So it's 4.5 comma 7.5 is the solution to that one. Alrighty, so that thus endeth the walkthrough of the cash cab. Hopefully this is something that you find useful and will enjoy. Until next time.